Ask a language model a tricky math or logic question, and it often blurts out an answer that sounds confident, but is quietly wrong. There's a simple trick that fixes a lot of that. You get the model to show its work, walking through the steps before it commits to a final answer. That single habit is the idea behind chain of thought, and it turns out to make models noticeably smarter. 3 ideas explain why chain of thought works so well. First, reasoning in steps. Instead of leaping straight to an answer, the model writes out intermediate reasoning, breaking a hard problem into smaller pieces it can handle one at a time. The classic trigger phrase is simply, "Let us think step by step." Second, better accuracy. On multi-step tasks like arithmetic, word problems, and logic puzzles, showing the work sharply raises the chance of a correct answer, because each step builds cleanly on the last instead of guessing all at once. Third, thinking time. Chain of thought is the foundation of modern reasoning models, which deliberately spend more compute at answer time, generating longer internal reasoning before they respond. That extra test time compute is what separates a quick guess from a carefully worked out solution. It helps to compare the 2 ways a model can answer. The direct approach jumps straight from question to answer. It is fast and cheap, but on anything with several steps the model is basically guessing, and small errors early on quietly ruin the final result. With the reasoning shown, the model writes out its intermediate steps before it commits to an answer, which gives it room to catch its own mistakes on multi-step problems. Let's pull the key points together. The model produces intermediate reasoning steps before it gives a final answer. It sharply improves accuracy on multi-step problems like math, word problems, and logic. It underpins reasoning models that spend more thinking time before answering, trading tokens and latency for quality. The takeaway is that making a model show its work makes it smarter, though the shown steps are not always faithful. For more plain language AI explainers, visit Standarity.com.